this demonstration, you'll learn about the simulation workflow in Discovery AIM by walking through a structural simulation of the effects of temperature inside a manifold. To start, we'll choose the template app that matches the physics we'll be solving, the structural template. In the initial step, we'll import an existing geometry, and then in the next step, select Thermal, keeping all other defaults. Click Finish to start the simulation. The simulation is made up of distinct but connected steps. Discovery AIM calls these tasks. The template creates the tasks of your simulation shown in the summary grid and in the Workflow tab of the View panel. Each task is a connected step in the simulation. Click on the task to open that task's data panel. Each task is a container for all of the objects and settings within that step. Although the starting template adds objects and default settings, you can change any of these to match your specific simulation. If you have questions as you move through the workflow, clicking on question marks will open different kinds of help. Let's start setting up the simulation. Because I enabled model editing, the geometry task is where I can edit the geometry file. Here, you can modify an imported geometry or even create a new geometry. Return to the physics simulation by clicking here. Now let's look at the physics task, the next task in the workflow. Here, we set up and solve the physics solution. Remember, all of the objects and settings defined by the template have defaults, but can be modified for your own requirements. A good strategy, especially for larger studies, is to begin with a lower solution fidelity that calculates quickly and then, if needed, solve again with a higher fidelity. The physics region defines the physics being solved, in this example, structural and thermal. The location field shows that all bodies in the model are part of this physics region. There are visual cues and messages to help you set up tasks. Attention required means that objects are missing or need information before you can update this task. The Messages tab summarizes the changes needed. Here's a blue color cue to add structural conditions. You can add objects here in the data panel. Let's add supports to the openings of the manifold using the face selection filter. Use the Control key to select multiple locations at once. To add faces or change a location, select the faces you want to include, edit the supports, and add or replace the faces. Right-click to add a temperature condition and apply it to a selected set of faces. The location is listed when you click inside the field. Let's confirm that the material is structural steel. Solve Physics runs the calculation and updates the physics task. Information about the solution is in the Transcript tab. With the physics solved, you can visualize the simulation in the Results task. The first thing you'll see is an interactive preview of some results. You can explore areas of interest before generating higher fidelity results. The template automatically adds 3 high fidelity results which have to be updated before you can visualize them. You can add more contours, calculated values, isosurfaces, or vectors to view the variables of interest. Now, updating the Results task evaluates the results. It's easy to preview or animate any of the results. You can even view them simultaneously. This completes a simulation in Discovery AIM. Once you've reviewed your results, you may want to make refinements or changes to the geometry or the physics setup and solve again. This concludes getting started with Discovery AIM workflow. In Part 2, I'll show you more about the Discovery AIM workspace.